Namaskar, I'm Harpreet Kaur and I welcome you all to our live and interactive session. You are watching this online training session under the umbrella theme of Integration of Virtual Labs in Teaching Learning Phase 2. When I say Phase 2, it means that this time in this particular training program, we are specifically catering to the audiences from the southern part of the country. It includes states like Andhra Pradesh, Karnataka, Tamil Nadu, Telangana and UTs of Puducherry, Lakshadweep and Andaman and Nicobar Islands. You are watching our live and interactive session on PM eVidya channels from 6 to 12 and also on our YouTube channel NCERT Official. Well, repeatedly I've been saying that it's live and interactive, which means you can participate in the session, you can be a part of it, you can share your questions, doubts, fears regarding the concepts, anything that you feel like regarding today's topic with us. And how you can do that? Well, we have different platforms for you. Please take down our phone number. It is 8800440559. Call us on this number. Also, if you wish to write an email to us, we have a dedicated email ID for you, and that is diksha.training@ciet.nic.in. Last but not the least, you are watching us live on YouTube channel NCERT Official. So please go to the comment section. Drop in your comments there. Your suggestion, your feedback is extremely important to us. And it's not just an online training session, but it's also an awareness program where we talk about virtual labs, why they are required, how they came into existence, and what all, upgradations are taking place in this particular scenario. We will also talk about National Education Policy 2020 because we are basically focusing on its objectives, and virtual lab is one of the outcomes of the same. So if there is anything that you would like to share, then please pay attention because there is going to be an assessment. It's an online training program, so you have to participate in the assessment if you feel like, and if you score more than 70%, you will be granted a certificate. I will tell you all the ways, to go through the website. You can actually read our write-up, you can learn who can participate. Though in the phase 2, we are specifically, targeting our audiences from the southern zone, but this training session is open to all. Anybody can participate, anybody can take the assessment, and anybody can take the questions answer session with our experts, and of course, you can share your feedback. Now, today is day 3 and we will be talking about virtual lab as a teaching learning tool for physics. Quite a heavy subject, but don't worry because we have our experts in the studio who will guide us that how virtual labs are playing an important role when it comes to physics. So let me introduce you all to them. We are joined by Dr. Jipsy Malhotra. Ma'am is Assistant Professor, MPD, CIET, NCERT, New Delhi. Ma'am, namaskar and welcome to the session.
Namaskar, Harpreet.
We are also joined by Dr. Uma Sharma. Ma'am is Academic Consultant from CIET NCERT, New Delhi. Ma'am, namaskar and welcome to the session.
Namaskar.
Now, before I directly jump into the question and answer and also share my personal experiences on physics, it's time to give you a brief overview. So, Dr. Jipsy, I request you to kindly share what exactly we're looking forward to in the session.
Good morning everyone. Today in this session of our virtual lab as a teaching tool for physics, we are actually going to deal with what is physics, how physics can be related to the daily life, and how in this physics, what are the scientific methods, and how with this scientific methods can be utilized using the technology, how it can be made easy, and how the students can practice again and again, how it can be all the labs can be affordable, and the students can see the picture which is in 3D and which we consider as an abstract concept. As Harpreet was saying, it's in a heavy subject. It's only because students think it's an abstract. But now with the use of technology, how we can make the physics also as an easy and the concept clarity, that will be our whole session.
Well, thank you so much. I'm curious to learn more about it. And Dr. Jipsy, in classroom scenarios, some students, of course, like me, they always struggle to connect with the subject like physics. It is because they find it too theoretical, or there are other factors. Because I remember when I was a student myself, I never had any inclination towards learning physics. I think it was too theoretical, too heavy, and concepts were actually not clearly understandable. What's your take on this?
Sure. Actually, the students feel that physics is a struggling subject because they are not able to connect this physics subject with the daily life.
Yeah.
Let's talk about the cricket only. Everybody, I think most of the Indians love to see the cricket, play the cricket. You know that most of the things in the cricket, the skills, the spinning the ball, hitting the ball, this all involves the physics. Only thing missing is when we talk about force, electromagnetic waves, we talk about the energy conservation, students are not able to relate these all concepts with the daily life, the real life examples. This is what is physics. If we are not relating the things with its application and all, it sounds in our mind that it's little tough, it's little more complicated, it's stressful. Now I would like to tell you, physics is actually deeply rooted in the lifestyle of ours. Physics itself has come from the Greek word which is called physikia, that is natural world, studying how the objects are interacting, how the objects will be converting the energy levels and all. So this is what is physics. Talking about a falling apple, I think many students know how the apple falls.
Yes.
But one of the kid in my home is saying, why apple is falling only? Why it's not going up? So these types of questions we neglect, and we say the kid is just talking a little absurd things, and we say no beta, this is the Newton law and this has to fall. Other than doing that, it should be actually we should make the child observe the things and then ask him, see, everything is falling downwards. So like this only Sir Isaac Newton has reached to the level of the universal law of gravitation. So this is how physics comes. It comes from observations, it comes from analysis, interpretation. Only thing is we have to spark the curiosity of the child.
Right.
So while sparking the curiosity of the child, they think that there should be a question and the question should be answered every time. But in our India, we have the population, we all know so much, it's the highest population in India. Teacher helping or any senior or the one who has no experience and helping each and every child is not possible. Here comes our virtual labs. That is the reason this has been created. National Education Policy says that every child gets the education, the qualification, the information at their own level. So this is where our virtual labs are being. So it will make our physics more interesting, and I think most of the students will start loving the physics. Another thing I will say, physics thrives on observations and questioning. So questioning we have already done. Observation, I will tell you, once there was a glass lying and two girls were, I was just sitting in the train and a mother gave a glass of water and the child just threw the pencil in the glass. I would like to demonstrate that thing also. I will just show you. Simply the glass was lying in the kitchen, in the train, and in this demonstration, what they were doing, the child says, oh, your pencil is being broken, and the mother says, hey, you have spoiled the pencil. This is what our Indians normally say. You have just spoiled the pencil keeping in the water. No mama, our pencil has been broken. See, it's getting tilted. And the sibling came and say, I will show you the magic, the pencil is okay. So what it was actually a verification going on, which our expert with me will be showing you the detailing and all. So how this angles are being broken, which child can't see from the natural, even if the child is in the lab. So this is where our virtual labs will be supporting us to give the more clear picture. Then as one of the biggest challenges to visualize the abstract concepts. I told you there is an angle, there is a denser medium, lighter medium. These are challenges which the students are facing, as there are also electromagnetic waves, which says that the wave is both wave and a particle. That is the nature of our rays. So understanding it as a wave as well as it as a particle is a little confusing. So here comes the technology is playing the part to show you the detailing, how it's acting as a particle as well as wave. Another challenge is lack of contextual examples. I think many students have loved to have a swing on the roller coaster. Do you know this all depends upon the energy conservation, the law of conservation energy. The moment the roller coaster is moving, you can see the movement. It's just like a pendulum movement. So it's mainly potential energy, kinetic energy conservation. These connections we are not able to make. If we start making these all connections, physics will be the interesting subject. Physics will be the loving subject. I really want to thank here on this live platform to my teachers who have taught me physics. They've really connected. They never teaches us. They just take us to the ground or make us play and then tell us this was the physics. So we start feeling connected, and I will not deny saying that there are lots of mathematical calculations and all also that. But every discovery needs some inferences. Every discovery needs some calculation.
True.
So this is how we remove this physics stress, and I hope the curiosity of the students can be maintained by connecting it with the live examples.
Well, thank you so much for explaining this in detail, and you demonstrated it well as well. You know, you're right that due to population or certain external pressures, teachers are more focused in completing the syllabus, and so many questions remain unanswered. I remember when I was a student, I remember these terms: kinetic energy, potential energy, Newton's 3 laws of motion,
exactly.
but could never connect with the real life, and that's why probably it was my loss or probably somebody else's loss that they could not develop a career in this beautiful subject that's not too heavy, as you mentioned, called physics. Now, in order to develop the interest of a child in a subject, we need some creative ways. It's not just theoretical. It's not just going to the blackboard and drawing figures and making them understand. Taking them to the laboratories, performing experiments, live examples, these all are important. So what, according to you, Dr. Jipsy, are some of the creative ways that can spark curiosity in a child for developing an interest in physics?
Okay, so as you are asking that how we can spark the curiosity, first of all, we have discussed that physics actually deals with universal laws.
Yeah.
It deals with behaviors, relationship. Physics is mainly experimentation and questioning. The more the questions, the more the curiosity, and more we move into the depth so that we get the solutions of those questions. Physics is understanding the physical object. That is physics. Physica, Greek word which we were discussing about that. So now how to arouse the curiosity is, physics is often perceived as an abstract subject. But to make it exciting journey for the students, what we have to do, we have to change the methodology. There are different approaches where the teachers can teach. First of all, I would like to say the experiential learning. This is what our national education policy is also focusing, that this experiential learning should increase. Experiential experiences has to be given. What type of experiences you can give? I have seen in one of the class, the teacher was teaching. She just piled up the books on the table and make one book as a slide. And then the teacher asked to roll a ball down. Okay, and when the students were rolling a ball down, the ball was just moved to one of the bench or first bench till. Then she asked to raise the platform and now roll the ball. It reaches to the third, fourth bench. Then she raised it more and asked the student to push also that. It reaches to the end of the class. How the teacher is teaching the acceleration part with the inclination and angle, that is what is experiential. Students, that's hands-on activities which the students were doing, they really remembered in the class. They don't have to study from the physics book. They know the moment the angle will be changed, the moment the inclination will change, our speed will increase, our acceleration will increase. Second is a personalized learning. Here in this generation of new generation where everyone has the mobiles in their hand, students have their own timings and all to study. They want personalized view also. No doubt teachers are the guiding light, teachers are the facilitator, but they love to have a personalized because they feel if technology can answer me, why should I ask? And they are little dependent. That is where our virtual learning plays a part. So in personalized learning, I remember when we used to do the focal length experiments in the classes and all, our half of the class time goes on adjusting the lens, focal length and having the image, I think. Okay, but now the students have the virtual labs, which has to be. This leads to personalized learning, also saving the time. Then is the collaborative learning. Yes, everyone is not liking the science subject. Everyone is not liking the language subject. So it's what the best technique is, make a collaborative learning. Whoever has the good aspect of whichever, somebody wants to make a connection nicely. Some knows how to write down the measurements and all. So let's have a collaborative so that every peer teaches the other. It becomes comfortable for the students also. They don't feel shy, they feel confident. That's a teamwork, and the values of sharing, taking responsibility of your group also increases. Another approach which teacher can use is demonstrative learning. Demonstration is very important part. I told you that it was by mistake only a child came and put the pencil in the glass of water. But that demonstration, that type of demonstrations, the teacher which piled up the books and all, that type of demonstration has to be done in the class, so that picture of real life examples can be really brought closer to the, but everything can't be brought in the class, so there are some complications.
Right.
Then is experimental learning. In experimentation learning, the experiments are given. I will say there are some light examples, inverted images, focuses and all. So in this experimentation learning, teachers normally give coil and all and see how much current is coming. When in magnetic field, when we do the electromagnetic induction, a light current is saying, and teacher says, oh, this is a solenoid and this the current is flowing and all. But if galvanometer is connected and students are able to see the diversions on the needle and all, they will understand, yes, this is the current being generated and all. So this type of experimental techniques should be used. Then comes interactive visuals. Oh, I told you, there are lots of abstract concepts in physics, in other sciences also, which are just, we were understanding with the lecture method, we were feeling as having a view that this must be happening. But now here is a virtual labs which is coming, which is giving the interactive visuals of how the magnetic forces and all is coming. I will be little demonstrating you that too, and one of my expert friend will be giving you the picture also of that. Then is flipped learning. Everywhere, including the technology, it's not wrong, but there is always a balance of whatever we do, excessive. So flipped learning is one of the things which has made the work easier, more interesting. And what they are doing is, teachers are giving this labs, virtual labs to the students. They're seeing the videos, they're trying the connections at home, and then they are entering to the actual physical lab. Because these virtual labs are not supplementary to the physical lab. These are actually complementary to the lab. So the students are knowing what is the steps, students are knowing what are the connections and all, and then they are coming back for having that actual physical labs, and that is time saving. That's actually making the students feel more confident, and they're clear about the concepts also. So this type of approaches, if used in the classes, it actually bridges the gap between theory and practice, and all the confusions and stresses which the students have because of the gap of the stress and all, not connecting to the real life, will be removed. Right. So this has to be practiced, and this will be fostering a lifelong love for our physics subject, because we are the physics persons, and we want everyone to know the physics, and they should love that subject. So this is one.
Well, you know what you mentioned about learning, it applies to all the subjects, and learning is quite subjective. Every child is unique. Every child has his or her own pace of learning, own difficulty level to attain and grasping the concepts. And here it is very important to make a child understand not just by lecturing but by demonstrating. And physics or science subjects are such that unless and until you show them that the process is happening, they won't be able to remember that. And you very rightly said in the beginning, it's all about connecting the subject with the user in everyday life. Otherwise, it becomes monotonous and boring. And here comes the most interesting part, when a teacher takes you to real physical laboratories to perform experiments. But sometimes we have a dearth of resources. Sometimes we cannot just make everybody perform the experiment due to so many reasons. So there are many challenges that a physics teacher faces while conducting the experiments and making the children understand. So Dr. Jipsy, let's talk about those challenges that exist in a real physical lab setting.
Sure. Regarding the physical lab, I told you virtual labs are important, but these are complementary and physical labs to the physical labs. First of all, talking about physical labs, I would like to tell you about significance of experiments. Why we are doing experiments, why it's necessary for the science students, and what is the significance. First of all, if somebody says you, hey Harpreet, you have discovered this. Yes, this is the right. Owning that, yes, I have found it out, that gives a true spirit of satisfaction.
My eureka moment,
Yes. So that is what this experimentation plays a part. Doing with your hand, that is validating the things, finding out the facts. Yes, I have discovered, I have observed, even if it's discovered, but for the students, it's really a self-satisfaction level. So this is called validation. So I will say, actually, experiments have a significance. This says physics rely on experimentation to validate the scientific concepts which is needed. Then is hypothesis testing. Regarding the hypothesis, I would like to say, concept of physics, we have some or other things in mind as we say the questions. There is one this box lying on the table, or any duster lying on the teacher's table, if we say why it's not moving, why it's not flowing, otherwise the ball was moving.
Yes.
So it's because this box is having a friction, it's having a, so this type of questions, why it's not happening or why it's happening, these are all called hypotheses. This is the tentative questions, solutions which we have in our mind. So concept of physics are difficult to grasp till we experience that,
Yes.
till we observe that, and till we question that why it's happening. So this is the significance of experiment. Have a question and experiment it.
Yeah.
Then is the data interpretation. While taking the measurements, we have to be very much clear that whether our readings are fine. I remember I just gave one, I bought a bottle, you must have seen these days, which has a temperature reading on. Have you seen? I think most of the audience must have seen.
Yes.
I gave that bottle to my one of the nephew. He was very small, of class 3-4 age, and I told him, whole day you see how much temperature is in the bottle. He noted it's 26, it's 23, it's 22. So it was a cooling effect, and it was a normal experiment. He was loving. He was saying that I have seen that now at time this was there. I asked him to make a curve. Okay, he was saying, what is curve? So his sibling just helped him, and he drawed that curve and all. So this is the cooling curve, beta, heat cooling curve. So this is how this data interpretation is being done. So if we start teaching us kids with a small experiment that how these readings are being done, so that is, they will start loving. So developing essential scientific skills of data collection, analysis, thinking, and problem solving techniques. This is how experiments are significant.
Right.
The more you are connected, the more you learn. You don't have to grasp the things through books only. It's your observations and readings, and he is learning the skill of observing the thing. He is learning critical thinking.
Yeah.
He is learning the skill of data collection and also problem solving too.
Yes.
So this is where. Then is engaging students. Engaging students is, I really remember once I visited the Science Museum here only in the Delhi, and I took my students with me, and they were asked to make a loudspeaker. That's truthfully, I'm just telling my truth story. And no doubt my students were B.Ed students at that time, but very well engaged with the science and all. But they really loved creating that loudspeaker, and they put the music. That creation of their hand, that engagement of the students at their age level. You think if this has been done with the class level also, they were everyone was storing that this aroused the curiosity, how I can combine the reading, how I can combine the sheet and all the that sheet was working as a speaker's sheet. So that advancements has to be done. And everywhere this paths are not available.
Yes.
So here comes our virtual lab. That is the reason National Educational Policy says, let's convert it into more technological so that everyone can experience this and own that achievement of them, that yes, this is our creation. So this is the significance of experiment. Now I would like to demonstrate one experiment and then tell you about what are the problems teachers are facing.
Sure. We can definitely have this experiment. It is reminding me of my childhood days. Probably I have also performed something like that.
Sure.
Yeah.
What I will like to show here is the magnet. It's a very simple experiment which I am going to show. Is it visible?
Yes.
Fine. This is the magnet I have kept. I think mostly in the schools this type of magnet is there.
Yeah, it's a bar magnet.
It's a bar magnet, and there are some of the pins. Okay, there is a 2 bar magnets I have, one moving. I will show you these bar magnets are lying and the pins are in just dispersed. I'm dispersing it here on the sheet. Okay. Now I will be bringing my bar magnet nearer. Let's see, it came and it aligns into the line. Okay, they were dispersed. So this is the magnetic, and it's a very simple experiment. I think many of the people have observed in their home also having a magnetic toys and all, and everything is aligning that. But how can we show that what is the distance where the things start, the iron pills start getting attracted? This distance question never comes in the mind. Okay, that how much the distance. Then we see that there are 2 bar magnets and one is attracting. If I change the side, it's repelling. So from where it start repelling? It doesn't start repelling from the distance. This distance, this observation and all. Why it happening? Why this distance only getting attracted? So there is some magnetic field around them. So this magnetic field is not visible. Now when we start talking about attractions, repulsion, students love physics, I know that. But moment we start talking about magnetic field, magnetic intensity, the lines of forces, students get disconnected. Now this magnetic field, magnetic lines and forces will be well covered with the virtual lab. Okay, they will be showing the concept. I can show you there is a magnetic fields around the conductor. This is a conductor which we can see on the screen. There is a magnetic field line. So this is the area where the attraction and repulsion forces are being acted. Now, regarding the magnetic fields affect our electric current, we can see there is a hand rule which is being visible. Teachers used to tell us, hold the pen, have a Fleming right hand rule, and these are the magnetic lines of force, and we used to think this is the magnetic line. But how much area they are covering, what is the direction they are following the magnetic field, this all virtual lab will be simulating us, showing us the virtual reality of the field lines and all. This makes our work easier. Regarding the physical lab, as you have asked the questions about what are the problems the teachers are facing in the physical lab and all. This physical labs, talking about the population of India, we know the population of India has crossed limits. Every class is having more than 40 students. No doubt physics labs are being constructed by the government of India, but having more and all 5 operators, 6 operators.
True.
And then in our class we have 40 students. Now, how this 40 students can be given the experience of same practical is little tough. So that number, or we can say item or resources, is one of the challenge which physical labs are being facing. Then is regarding the instruments. With the time and all, the instruments are getting turned and all.
Wear and tear is happening.
So while measuring the degrees, while measuring the ratings of this science experiments, with the what happen is the readings and all the measurements is not as accurate. If we talk about let's measuring the angles only, the protectors are little broken or torn, or the lines on that readings is little lighter and all. So maintenance of that is also tough. So this is also one of the issue. Another thing is there are some experiments as I say light experiments, some optical instruments, some laser lights, some experiments of radioactive and all. These experiments need a very costly instruments. Every physical lab, every school can't have these type of experiments all. So here comes the picture of our virtual labs, which will be the answer, and I think very clarity. She will be my friend will be giving the examples on that, how it can be well covered. Physical labs, I will also want to tell you one truth is, when we enter into the physical lab, we don't have much infrastructure as compared to our population. It becomes crowded when the teachers enter with the 40 students and all, and it's really difficult for the teacher to cover up that messy crowds, the noise, because if we are doing the sound experiment all, we use tuning forks, it gives the vibrations and all. Okay, how to measure those vibrations, how to cover up that tuning forks, that gets disturbed with the crowd if we have in that. So these measurements, these readings get affected. So this is one of the challenge which we are facing in the physical lab. Then is accessibility. Sometimes we have some special children. Sometimes we have some students who are ill also. If we say having that experiments experience, having that experiments processing that experience can't be done if we don't have that physical lab.
Absolutely.
Truthfully, I will say that no doubt physical labs are actually the hands-on experiments. It's the real picture, but virtual labs should be included because it is the complementary part. It saves it's cost effective. It gives more experiences of 3D things and all. So that is how the physical lab challenges are being faced.
Right. I mean, you have reminded me of my good old days. I remember waiting for my turn to perform experiments, and you rightly pointed out there were not enough resources, and then we have specially able children also, and then there were external factors because you really can't control the variables in a physical laboratory all the time, and that adds to the delays in performing the experiments. But when you are engaged in something right from the beginning, you're involved in the process, you're creating something, discovering something, you're having your eureka moment, and it is so satisfying and fulfilling as a student that you feel like you're a little inventor out there. But there are limitations, as we discussed, in real physical laboratories, and we are also talking at the same time that these limitations are appropriately addressed in a virtual lab setting. So Dr. Uma, I would like to ask you this thing only, that how virtual labs are actually addressing all these limitations that we are finding in real physical laboratories.
Yes, ma'am. Of course, I agree with the Jipsy, ma'am. She has very well explained what are the challenges we are facing in physics lab. So here comes the virtual lab, which facilitates this physical lab.
Right.
So exactly, first thing is it based on the concept of remote experimentation. Like as ma'am already said that like a virtual, like we can say that just give me a moment.
Sure.
Based on the concept of remote experimentation, like some in rural areas, those practical labs are not feasible for all the students, and as per NEP 2020 recommendation, we have to give access to all the students which are poor or other regions.
Yes.
Okay, so we have to consider that thing. And second thing is though there is no substitute to hands-on experience of a physical laboratory, virtual labs have a great potential to enhance actual laboratory experience with their unique features. And what are these unique features which I will cover in the demonstration, that interactive simulations are there, videos are there, like lots of theory, practicals are there where students can perform repeatedly those experiments without using those resources. So this is a one advantage of this virtual lab. Plus it is a very simple thing, it is a computer based activity, like where simply learner require a computer system and it requires an internet facility, and anyone can access this virtual lab facility at the home. So this is the one of the feature, right? And first ma'am has already explained about these things. So the virtual lab have a resource rich learning environment. That means all the resources like theory is there, procedure is there, step by step animations are there, simulated videos are available. So these things are already available in this virtual lab. So this makes a unique like any advantage for students to learn in a comfortable manner.
Right.
So in the picture you can see that anyone can learn anywhere. If the physical lab is not present at the particular location, that particular resources are not available there. So they can go at home also, in class also, with the help of simply internet we can access this virtual lab. And one more thing I would like to say that the idea behind setting up the virtual lab is that it can be used more efficiently in a cost effective manner, right? So this is the one thing. And one more thing is there, virtual lab, and how does it enriches the learning. I think this is a
another question. I was about to ask this question, and you rightly said, you know, we have so many advantages of establishing a virtual lab. You can learn at your own pace, you can actually connect the last mile learner, you can make education accessible to all, or you know, actually making education reaching not just the doorstep but the hands of the learner. You can literally go anywhere, travel, you're in transit, traveling, studying, or just having fun. You can immediately log on to a virtual lab and perform the experiment. But as we talked about physics, there's so many abstract concepts. So, Dr. Uma, how do you think that these virtual labs, they enhance the students' understanding of all these abstract concepts in physics?
Yes, absolutely. Like a virtual lab is a boon for enriching the teaching learning in the case of physics and other subjects too. It helps to observe, inquire the particular process and phenomena. For example, light waves. So light waves are like a student, a learner cannot see a light wave, how light wave travel, okay, and how they travel in a different media, what will the velocity in different media. So they can observe that phenomena in virtual mode again and again to know the exact fact about it, right? And second thing is it keeps the learner to engage to manipulate, like I said that when the light travels with a air medium or in a vacuum medium or in a glass medium, what will happen to its velocity of light? So its velocity obviously decreases. That thing they can easily manipulate in the case of a virtual lab, which is not feasible in a normal physical lab, right? And second thing is like once the learner is doing continuously learning all these things by his own pace and with a question and trial and error method, it deepens the conceptual understanding and again which gives the motivation to the learner, right? And this virtual lab has a very unique feature that we can visualize the abstract, the invisible concept, as ma'am has already explained about this thing, like atomic structure, propagation of waves, sound waves, light waves. So these are all abstract concepts are there, which the students cannot see in a normal way, but when we are we can make them like I will demonstrate this also in a demonstration part, how these abstract concepts can be feasible to them.
Absolutely. I mean, you're absolutely right, and I often quote this example that virtual labs can make you not just imagine things, but you can watch them. Like if current is passing or flowing through a certain medium, you can actually see how the current is flowing. You just not imagine that it is there. You're right.
Okay. So one by one, I will add some examples.
Sure.
Okay, like virtual labs gives a personalized learning experience to all the learners. Okay, the learners can learn at their own pace. And second thing is like the complex physics concepts like conservation of momentum. Okay, like in the case of a collision. Okay, so how momentum is conserved in that case, that can be done easily explained in this virtual lab experiments.
Okay.
And it gives a real time data processing for immediate results. Like for example, I will give one example. I will explain this with one example, like when in the case of mass, force or angle or refraction case, as the angle of incidence changes, immediately the angle of emergence is also changes, and we can know that how the what is the path of the ray, what will the path of the ray, which is not like in a normal physical mode, students are unable to grasp that thing.
Absolutely.
Okay. And like there are some experiment like in thermal physics experiment, which are very lengthy, which cannot be completed in assigned practical lab periods.
Okay.
So these lengthy experiments can be easily like streamlined along the virtual lab thing. Okay. And apart from that, controlled environment and unmatched precision and accuracy is a key feature in the case of a virtual lab. Like Ohm's law, for example, Ohm's law, it is done in at controlled pressure and temperature. So we can easily control that pressure and temperature in the case of with the help of a virtual lab. And with the virtual lab also gives a pre-lab and post-lab sessions with the help of virtual lab. Like we can assign students to work on the theory part, experiment part beforehand coming to the lab, so that they can have an idea what they have to do during the practicals.
True.
Okay. And after the practicals, once the practical is done, they can do the post lab session, and we can assign some activities related to that practical during the with the help of a virtual lab. So this is a unique features.
Right. I mean, thank you so much for sharing such examples of physics experiments that can be performed really well. And I hope that you have some more examples that you can share with us. And you are absolutely right that you can get not just the desired outcome, but the accurate outcome, because you can control the variables. And we have so many experiments that are there in virtual lab, and ma'am is going to share some examples with us. Yes, ma'am.
There are some examples, as you can see on the screen, that some mechanics examples are there, optics are there, refraction, electricity, which I have demonstrated further. Okay, right now, like these are certain examples which are all are abstract example, which can easily we can explain with the help of a virtual lab, giving a insight of what exactly happening for these main phenomena like refractions or reflection, other things.
All right. So, we have talked about these examples, and we know that there's so many other things also that happens in virtual lab. Apart from performing experiments, learning is customized, personalized, as you have learned. You can increase the difficulty level at your own pace as per your own understanding and convenience. But there is one more thing that's very important, that is assessment and evaluation. How you are going to assess yourself, or how a teacher is going to assess a student, that whether the student is performing up to the mark or not, or there's still some more practice is required. So, Dr. Jipsy, let's talk about these assessment portion of a virtual lab, that how they can be integrated for assessment.
Sure. A very main question, important question is assessment.
Yes.
So every child wants whatever he studies, that should be given a either we can say some good or rewards,
Great.
or either in the type of marks or grades and all. Or here comes the assessment. As ma'am has told about the virtual labs and all in detail, no doubt virtual labs also help in assessment. I will just want to show you the picture I have already shown on my screen. Just wait. Yeah, as you can see in the screen, in this virtual lab, there are 3-4 portions. First is theory, on the first tab you can see, then is procedure, simulator, and self-evaluation. This question mark sign you can see there written self-evaluation. So this evaluation part has been embedded in this virtual lab. So what is in the virtual lab is they gives us the questions, they give us different types of questions and all, which will be virtually shown to you also. Some demonstrations will be given by ma'am, and these questions help us to give this evaluation, to give the feedback. Assessment. I will share you one scenario of the physics lab. There was the connections. We asked the child to make the circuits and all. While making the circuits, the students were divided into groups. As in the Indian classes, it's done. 2-3 students made the connections and give the reading, and they said, "Ma'am, we have done that." Okay, and the measurements are being done. But there was another group in the class who was not able to make the connections, the positive, the negative terminals, joining it to the voltmeters and all. And they were more pressurized when the first group said, we have done. That stress, that strive. And then how the teacher will be evaluating. She is having 40 students in the class, and she has to evaluate each and every one whether the connections are being done or not. So this all purpose can be very well solved by the virtual lab. What happens in the virtual lab is, if the connections 3-4 times the child is not able to make the connection, they open the references and all. They open the videos, that is the simulations of that. As I have shown you in the screen only, that there is simulation part also. So if the feedback is not going good, it is being connected to the video part. So this type of evaluation, the assessment is being done, and the students can with the quick feedbacks and all through the screen, that you have put the wrong connection, you have to connect it to the positive, or go to the simulation back and all. This increases the positiveness. We don't have to give the negative marks. Major purpose is to make the student learn that skill. So that is where the assessment is being integrated in this virtual lab. Another thing is data collection and progress tracking. I told you the main thing in the labs is that the instruments get torn, the instruments get old and all, and the measurements and degrees are not that appropriate. Sometimes the external variables are reacting, the independent variables get get molded and all. But in this virtual lab, everything is fixed. Students, if they are measuring the refractive index and all, they will measure the exact amount by changing the degrees. One more thing, while assessing the things, if the child want to assess Ohm's law only, which ma'am will be virtually showing also. Do you know which is the best conductor as per you?
So I was not a good student.
Okay, the wires are made up of copper only. You know that?
Yeah.
Because they are thinking that this is the conductor.
Yes.
But the best conductor is gold and silver. But why it's not make? I think gold is costly. So that is also one of the thing. But if the child wants to see the best conduction and all, virtual labs helps in that.
Wow,
we
lovely.
can't present the gold wires or silver wires. So here comes the virtual lab. So assessment, doing different materials, assessment, minute observations is very well done with the virtual lab.
True.
Then is the adaptive feedback. I told you, if the child is not doing, he can move into the simulations and all, and that adaptations of whatever the wrong thing steps we were doing. Teacher just have to go on the screen and see what are the readings they have done, whether the chart is being made and all. So it makes it easier for the teacher also to do that. Then there are different types of evaluation techniques. I will just tell you about. There is formative, diagnostic, and self-evaluation. Formative is that we want to at every time check whether the student is doing right or wrong. That a small unit test normally in our schools and all. And while using the virtual lab, interactivity is there, because virtual simulation students are actively engaged in that, and they get the feedback at every step that this is wrong, otherwise the readings will not be there and all. Then is the data collection. Performance data, whatever the data you have performed, enables the teacher to track the students in the virtual lab. Then is adaptive feedback. Students adapt to this feedback given by the AI world or the virtual world and all, and they start scaffolding what are the steps, right steps and all, and they start reaching to the ideal path which is needed.
True.
Then is diagnostic. Diagnostic is pinpointing the specific areas, students struggling, where the students are struggling. So wherever the students are doing the misconceptions or some frequencies or amplitudes are if being wrong, they will mainly show the frequencies, videos, concepts of frequency will pop up on the screen. So that is what is the diagnostic feedback. They diagnose where is the problem and the personalized feedback is given according to that. Self feedback. Students get the feedback themselves because they are on the screen and the screen is not working, the readings are not being shown and all. So this is how the assessment. This assessment actually plays a very important role for making them motivate from one level of the study to the another level. So this is also one of the important part. So here we can say that formative, interactive, diagnostic tools and all are actually the insights for the students for what to do and how to learn these things and where is the other students have reached, and they start working for that.
Right. So we can say that you don't have to compare yourself to anybody and add that additional stress on yourself. Just lock yourself in a room or sit in a library or wherever you feel like, perform the experiment, repeat it until you do it right. And you can never go wrong in a virtual lab setting even if you want to, because you get regular prompts, you get tutorials, you get help and everything. And now Dr. Uma, since we are talking so much about virtual lab, I request you to kindly perform some experiment related to circuit probably, because this is somewhere generally students feel certain level of difficulty. So can we have that experiment please?
So first of all, I would like to tell you how to open it.
Yeah.
So for that you have to go for diksha.government.in. I have shared that screen on the screen. Kindly go to the screen, and there are different verticals are there, focus area of the Diksha, and in this vertical they have to search for the virtual lab.
Okay.
So once the virtual lab is open, you will get this kind of page in which from class 6 to class 12th all the virtual content is available in both English and Hindi medium. So where the students can do the practicals in the virtual mode. Okay, so I will explain here once for the class 12th, which is the Ohm's law one. So this is the how to reach it also I will explain to it. Simply you can go to the class 12th English medium, and there you can see that math, physics, chemistry, biology, in all the subjects this content is available, virtual lab content is available. And for class 12th I have opened for the English. I will directly go to the opened one here. So this is the first practical, which is Ohm's law, which states that the potential is directly proportional to the current. Here you can see that different unique features are there. Different unique features are available, like theory, procedure, animation, simulator, video, self-evaluation, resources, feedback. So these are all the features of virtual lab which is provided for each and every practical. So student can see the theory from here. Okay, what is the aim of that experiment, what is the theory of that experiment. Okay, so he can go thoroughly. Then there is a procedure, the detailed procedure is there. Then animation. So if he doesn't know about how to do the practical, he or she can go through that animation part and see the entire practical here itself in an animated mode, and then come to the simulator. Okay, so in the simulator, actually we can do that practical in a which gives the near to real experience as in the lab case. Okay, so as ma'am has told that silver is gold is a best conductor, right? So we cannot give this gold or silver to students. In lab we have only one set of wire is available, which is copper, and it is also having the same area of cross section, and same area of cross section is also same, and same okay, and length is also same. Okay, sometimes length is also same. So to change, we can in this virtual lab case we can change its length also, we can change the diameter also. So hence the resistance of the wire also get a change. So student will get the insight of what is the resistance, what do you understand by the proper resistance, how on what factor resistance depends. So this conceptual knowledge will be clear to on this. Second thing is in connection, they are not comfortable in connecting every time some wrong connection is there. So they can practice those connection over here itself. They can do the entire practical here itself. You can connect it in this way, and the wire is connected over here. Simply you can see as per if he forgot what is the connection, he can easily go to the show circuit diagram. Show circuit diagram, the circuit is available, and he can see check the diagram and if some point is missing, he can directly go to this thing. Okay, so here, so once the connection is done, as soon as key is closed, we can see that the ammeter and voltmeter is showing reading, right? So these readings are, we can simply put it over here, and we can direct at a instant we get the result in the form of a graph.
Right.
So this is the best unique thing, that it gives a real time experience, and that at the same point they can get the result. So this is the one experiment. They can repeat this experiment with a different wire also, gold wire, aluminum wire, iron wire, and check their resistivity also.
Right.
So this is the best part of the virtual lab. Similarly, I want to show you another practical which is of grade 10th. Okay, so again we can go to a virtual lab page. Okay, from here, from diksha.government.in, we can go to the virtual lab page.
And what experiment, ma'am, it will be, and for which class?
For 10th, class 10th.
Okay.
Okay, so I have directly opened it over here. You can see this.
Sure.
So class 10th practical, which is related to optics, like what will the refraction, how the images will be formed, okay, what are the condition for real images, what are the condition for virtual images. Okay, so here this I have taken a concave mirror to study the reflection in concave mirror. This is a practical to study the reflection in concave mirror. Now again, theory is available here, procedure is available here. So for the simulation, 2 minutes. Okay, for simulation is there. So you can see it over here, this object, just you can see when object is, I can just, I think it's got hanged.
Okay.
No problem.
Yeah.
No problem. Here you can see this one, the Snell's law of refraction, in which we can simply, you can see that angle of, I can change the angle of incidence and the reflection, and you can see the emergent ray, how the emergent ray are coming. Okay, so these are the show pins, show labels are there. You can simply change it, and we can see what will how the path of the light is changing when it is passing through a different mediums. So how light depends on the refractive medium. So at instant go, they can get the idea of a refraction of light.
Well, it's so interesting. I myself feel like performing an experiment here, but we are running short of time. So we have to wrap up the session over here. But it was quite interesting to learn about virtual labs and their use as a learning tool for physics. Of course, we performed some experiments. We learned the theoretical part, and ma'am also demonstrated some simple experiments in reality physically. You know what, I have to admit that nobody taught me that you have to calculate the distance, you know, when a magnet starts attracting things or repelling things. But that is quite interesting. So today we had our this beautiful session, very interactive, informative and eye-opening, regarding virtual lab as a teaching learning tool for physics under our umbrella theme of integration of virtual labs in teaching and learning phase 2. I would like to thank both my experts, Dr. Jipsy and Dr. Uma. Thank you so much. Thank you so much for your contribution to the session. And now, before I wind up this session completely, it's time for me to take you to the website. I told you in the beginning, it's going to be a training program and you can get yourself a certificate. How? Well, let's see. So just have a look on the website here, and you have to log on to ciet.ncert.gov.in. That's our website. Go to the activities section and opt for workshop and training option. Scroll down, you can see 2 activities going on here, and for the moment we are focusing on online training on integration of virtual labs and teaching learning phase 2. Here you will find a complete write-up of this particular training program, why we are conducting it, what are the objectives, and who all can participate. Anybody can participate. This is the entire program schedule where we are telling you about the topics, about the resource persons, and we are also uploading our videos. Whatever sessions are being done, they are uploaded on our YouTube channel NCERT Official for your later references as well. And now how to participate, that's the most important part. So first step is to register yourself. Either click on the link or scan this QR code. Second step, watch all the training programs very attentively. They're streaming on these platforms. Number 3, if you wish to participate in the assessment, that's going to happen on the last day of the session. So details are here, deadlines, when it will be opened, and if you score more than 70%, you will be getting a certificate. Last but not the least, Step 4 is submitting your feedback. That is extremely essential, indispensable, I would say, because unless and until we hear from you, we won't be able to improve upon our training sessions or include the content that probably is more relevant and more useful and required by you. So you can always write to us on diksha.training@ciet.nic.in, or you can give us a call on this number. So with this, it's a wrap. But before I leave the studio, let's take a quick look at the schedule, all the programs that are coming ahead. So watch it out on your screen. We started the day with our program Yog Shakti, and we've just concluded our session on virtual labs. In a short while from now, you can watch our session. Definitely there's going to be about digital literacy under Ullas. Then from 12 p.m. we'll bring you a session on mathematics, and from 2 to 5:30 there will be back-to-back sessions. 2 o'clock we'll bring you a session on EVS, followed by a session on Urdu at 2:30. 3 p.m. will be the time for a session in Hindi, where we will be talking about goal, Major Dhyan Chand. 3:30 to 4 p.m. will be the time for a session on Samajik Vigyan. And 4 to 5 p.m. is the time for our online training session, where these days we're talking about Internet of Things, IoT devices and its safety. Last but not the least, 5 p.m. will be the time for our session, Sahyog. With this, it's a wrap. This is me, Harpreet Kaur, taking leave of you. Please stay tuned for more educational programs. Namaskar.
अब जाके क्या खाए भटूरे